Right, and this is a optimization problem with a running track that you probably have at most of the high schools, or the people who are watching this have been on one of these many times. Okay, so the length of most tracks is 100 meters. The length is, and then I go around the whole thing, it's 400 meters. We're going to do a little optimization problem and see if that's actually the most ideal track. So we first need to show some parts before we get that. It says show that the length is 200 minus pi x. Okay, so we know the whole thing is 400. So 400 equals, well, what makes up 400 meters? Well, we have a length and another length. So we have two lengths. And then we also have half a circle. That's 2 pi r, divide 2. 2 pi r, divide 2. And actually, we've got two of those. So we can just 2 pi times r, and r is x. The radius is x. Okay, so then the length, if we start moving some of this stuff away, we get 400 minus 2 pi x equals 2l. And then divide by 2, we get 200 minus pi x equals l, which is exactly what we have here. Show that the area inside the track is 400x minus pi x squared. Now this is very common in optimization problems. You've got to isolate everything to one variable. Instead of l's, we've got only x's. So let's just start with l's and x's first. So the area is 2x times l. So that's the area of this rectangle on the inside. So 2x times l plus, and then one full circle. We've got the top half up here and the bottom half down here. So that's pi r squared. So pi r squared. All right. That's not what we have here. They have only x's, and we've got x's and l's. So we need to get rid of that l. So what is l? Well, luckily they asked us that already. L is equal to 200 minus pi x. That's very, very common in optimization problems, is you'll have to use two equations and isolate the function that you want to optimize down to one variable. So 2x, 200 minus pi x plus pi x squared. Okay, let's simplify this. Should come out to this. We have 2x times 200 is 400x. I see it happening now. Minus 2 pi x squared plus pi x squared. And then that is 400x minus 2 pi x squared plus 1 pi x squared is a minus pi x squared, which is the exact same thing we have here. Okay, so now we need to optimize the area. We want the largest possible area in the track. So area equals 400x minus pi x squared. A prime is equal to 400 minus 2 pi x. I need to know when this is a maximum, so set this equal to 0. So minus 400 divide minus 2 pi is equal to x. So that's 200 over pi equals x. There's our x value. Let's plug that in and find out what L should be. So 200 minus pi over 200. Just plugging it into this equation right here. And you see that things cancel. 200 minus 200 is 0. Well, that's weird. L needs to be 0 in order for this to be the best area, which means that we have one big circle for the biggest area on the inside of a 400-meter track, which I'm pretty sure none of your high schools or schools in general or any track is a perfect circle.